Hello everyone. In this lecture we are going to start system of equation. First we will do system of equation involving two variables and then we will continue with three variables. So first system of equation involving two variables. So equation is given as a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. We will divide it into two parts. First is consistent and second one is inconsistent. Inconsistent system of equation has solution. अगर कंसिस्टेंट है तो उसके पास सॉल्यूशन होगा और अगर सिस्टम इनकंसिस्टेंट है तो कोई सॉल्यूशन नहीं होगा. सिस्टम ऑफ इक्वेशन has no solution. Now we will divide it into two parts. सॉल्यूशन एग्जिस्ट कर रहा तो यूनिक भी हो सकता है, इनफिनाइट सॉल्यूशन भी हो सकते हैं. तो यूनिक सॉल्यूशन कब होगा? यूनिक सॉल्यूशन इफ a1 by a2 is not equal to b1 divided by b2. एंड इनफिनाइट सॉल्यूशन, फाइनाइट सॉल्यूशन कब होंगे? जब a1 अपॉन a2 इज इक्वल टू b1 अपॉन b2 इज इक्वल टू c1 अपॉन c2. और ये सिस्टम हैज़ नो सॉल्यूशन, ये कब होएगा? व्हेन a1 अपॉन a2 इज इक्वल टू b1 अपॉन b2 इज नॉट इक्वल टू c1 अपॉन c2. ओके, अब ये क्या रिप्रेजेंट करता है? इन दिस पार्ट इक्वेशन रिप्रेजेंट्स intersecting lines. And in this equation represents coincident lines. And in this system equation represents parallel disjoint lines. Okay, now if we have, if del 1 is equal to b1 c1 b2 c2, ये डिटरमिनेंट कैसे बनाया हमने? फर्स्ट वाले कॉलम को छोड़ दिया. मान लो हमारे पास ये है a1 b1 c1 a2 b2 c2 टू d1 d2. ओके, जैसे इक्वेशन गिवन है a1x b1y c1 इक्वल टू d1 a2x 0 b2y c2 equal to 0. Okay, so if we have del 1 is equal to b1 c1 b2 c2 b1 c1 b2 c2 and del 2 is equal to c1 c2 a1 a2. Similarly, del 3 is equal to a1 to b1 b2. Then we have x is equal to del 1 upon del and y is equal to this is equal to del 2 by del. Okay. Now let's talk about system of equation involving three variables. We are given equation as x1 plus x b1 y c1 z is equal to d1 a2x b2y plus c2z is equal to d2 and a3x plus b3y plus c3z is equal to d2. To solve this equation, to solve this system of equation, we define following determinants. The first is del is equal to a1 b1 c1 a2 b2 c2 a3 b3 c3. del 1 इज इक्वल टू फर्स्ट कॉलम को रिमूव कर देंगे b1 फर्स्ट की जगह del 1 में क्या हो जाएगा, फर्स्ट वाले की जगह d1 वाली रो आ जाएगी, del 2 में सेकंड वाले की जगह आ जाएगी और del 3 में c1 थर्ड कॉलम की जगह d1 वाला कॉलम आ जाएगा. सो del 1 इज इक्वल टू del 1 del 2 del 3 b1 b2 b3 c1 c2 c3. ओके. सिमिलरली del 2 इज इक्वल टू यहाँ पे a1 a2 a3 d1 d2 d3 c1 c2 c3 and similarly del 4 is equal to here a1 a2 a3 b1 b2 b3 d1 d2 d3. Okay. Now following algorithm is used to solve the system of equation. Algorithm is used to solve the system now we check the value of del determinant. Then 1 minute. So we check the value of del. If determinant is non-zero, then consistent system and has unique solution. Unique solution. And what will be the solution? X is equal to del 1 upon del, y is equal to del 2 upon del, and z is equal to del 3 upon del. Okay. Now if del equal to 0, we will check the value of use of del 1, del 2, del 3. So in this case, if at least one of del 1, del 2 and del 3 is not 0, not 0, then system is inconsistent. Then system. And if del 1 is equal to del 2 is equal to del 3, all are 0, put z is equal to t and solve any two equation to get the values of x, y in terms of z, t, terms of t. Now if these values of x, y and z in terms of t satisfy the third equation, then consistent system and system has infinite solution. The values of x, y, z if doesn't satisfy third equation, then inconsistent system. Okay. Note: first one is trivial solution. In the solution set of system of equation, if all variables assumes 0, then such a solution set is called trivial solution. Otherwise, the solution is called non-trivial solution. Second, if d1 is equal to d2 is equal to d3 equal to 0, then system of linear equation is known as system of homogeneous. Linear equation. Which always possess at least one solution, which is 0, 0, 0. Now third is if system of homogeneous linear equation has non-zero solution, zero or non-trivial. Solution, then the determinant del equal to 0, and in such case given system has infinite solution. So it's end here. Next we will do in the next lecture.